Hello and welcome to a ramble with me. We are rambling about IEB May 2025 paper 1. Question 12. A skateboarding ramp is created using the curve of a parabola. Exciting. The vertical distance from the top to the bottom of the ramp is 1.5 meters. Okay. The horizontal distance from the start to the end of the ramp is 12 meters. The bottom of the ramp is at B. If Halima starts at the top of the ramp at S and travels 1 meter vertically down to H, what is the horizontal distance X from Halima at H to the bottom of the ramp at B? Leave your answer in simplified third form. What a wow, what a wow, what a wow. Amen. The world is your oyster. You decide where you want your x and your y axis to be. Completely and utterly up to you. I am going to put my x axis here. I want to put it where the turning point is. Hibo. Guys, how can you not see my vision? Not ruler. It's more like it. Move my ruler after such impeccable placement. Right. Okay. My y-axis, I don't think it's really important for me to commit to any particular placement, but I guess I'll put it here. Okay. Right. So I'm going to treat this as my origin. Okay. So what we know is that the coordinates of S are 0 and 1. What? No, we don't know that. Yeah, we just know that the distance between S and H, the vertical distance is 1 meter, and then we don't know how much further down B is from there, right? So actually it probably makes more sense to, oh heavens, maybe let's move this guy here. What do you guys think? Then I am able to say the coordinates of S are 0 and 1. The coordinates of H, we don't know how big this distance is, but yeah, we've chosen our H so that it's on the x-axis, or we've chosen our axis so that H is on the x-axis. And then B, we don't know the x coordinate, we don't know the y coordinate, but we are particularly interested in the x coordinate because we want to know how far H and B are horizontally. So if H is 2 and this one is 5, then we know if the x coordinate of H is 2 and the x coordinate of B is 5, then we know that they are 3 meters apart horizontally. Right. We also know that the horizontal distance between S and E is 12 meters. So the coordinates of E will be 12 and something. I assume that they are at the same vertical height, but oh guys, they did give us, anyway, but they didn't tell us that, yeah, so this could be, what if it's a ramp like this that ends up there and even though visually it looks like they are on the same level, but they might not be. They didn't tell us. Okay, and I just noticed now that they did tell us this distance, the distance between the vertical distance between S and B, right, is 1.5 meters. So we do actually know the y coordinate of B, right? It's going to be negative 0.5, right? Because it's 1 meter down and then another 0.5 meter, and then we get to B. And to find the x coordinate, well, we know that the turning point of a parabola lives on the axis of symmetry of that parabola. So if we were to draw the axis of symmetry, it would be this guy, right? And so knowing that we have these 2 points that are 12 meters apart, that means that from here to here horizontally is 6 units, and from here to here horizontally as well is 6 units. So then that means that the coordinates of B would be 6 and negative 0.5, right? And what are we looking for? I'm so confused. So we are looking for the horizontal distance from here to here. Okay, right? And what do we know? Okay, we know that H is an x-intercept. So I'm guessing then we need to find the equation of this curve and then find the x-intercept. And what do we know about this curve? We know we have this point, we have the turning point, which tells us a lot. So yeah, so let's say that the curve is given by the form blah blah blah. Okay, we know that when x is equal to 0, y is equal to 1. So we sub in our 0, and we are left with that. So then we know that our f of x looks something like this. Okay, secondly, we also know, so this turning point is giving us 2 bits of information. We know this is a point on the curve, and secondly, we know that this is a turning point. This is the turning point of the curve. So this is 2 pieces of information for the price of 1, which is just incredible, right? So we know first of all that when the input to the function is 6, the output is negative 0.5. So if we put 6 into our x, what we get out is negative 0.5. So let's go ahead and solve that. So that, well, okay, we're not going to be able to solve it because it's 2 unknowns, but it's giving simultaneous equations. So I'm going to put all my constants on one side. So this will be negative 1.5. Then let's just times by 2 because we do discriminate against fractions here. Right, and then divide by 3 because it's common. Right, so this will be equation number 1. Secondly, we know that the value of the first derivative when x is equal to 6 is 0 because the turning point occurs when x is equal to 6. So let's find the first derivative of f. So that will be 2ax plus b, and, well, okay, sorry, jumped the gun there. So we're not at imply stage there. So the first derivative is, as I said, 2ax plus b. So we know that f prime of 6 will be given by that 12a plus b, and we know that 12a plus b is equal to 0. Right, and so therefore that will be our second equation. Now we can solve simultaneously. So the first equation we have is this guy, and then the second equation we have is this guy. Right, if you know me, you know that I love to solve by elimination, so I can immediately see that there's an opportunity very close by to eliminate the a's if I just times this by 2. So I'm going to times this by 2, the second equation, so that will be 24a plus 2b is equal to 0, and then we subtract the first equation. Well, so I would label this my third equation, even though it's the same as the second one. So I'm going to subtract equation number 1 from equation number 3. Okay. So if we say 24a minus 24a, they eliminate each other. 2b minus 4b is negative 2b, and then 0 minus minus 1 is positive 1, and so b is negative a half, and then sub b is equal to negative a half into whichever equation makes you happy. I'll just put it into 1. So then we have 24a plus 4 times minus a half is equal to negative 1. So 24a minus 2 is equal to minus 1. So 24a is equal to minus 1 plus 2, which is 1. And then we divide by 24. So a will be 1 over 24. So these are all the bits and pieces all together. So a is equal to 1 over 24, b is equal to minus a half, and c we found first to be equal to 1. So therefore the equation of our curve is 1 over 24x squared minus a half x plus 1. So let's just sanity check a couple of things. So let's see, if I do put in x equal to 6, I'm expecting to get out y equal to negative a half. So let's see if that's what we get. So 1 over 24 times 6 squared minus a half times 6, and then plus 1. And I do indeed get minus a half. And then my turning point, I'm also expecting to occur at x is equal to 6. So I'm going to use that formula that says x, coordinate of turning point, is given by minus b over 2a. So in this case it will be the b will be minus a half, fraction on fraction on fraction, minus a half. Okay, and for those of you who are getting heebie-jeebies, minus 1 over 2 is the same as minus a half, but anyway, I'll just put that minus there for peace of mind. Minus a half divided by 2a, right, and indeed we get that our x is equal to 6. So this is looking like the real deal, right? Why were we getting this? We're getting this function because we're trying to find the coordinates of h, which is one of our x-intercepts. So let's go ahead and find the x-intercept, which occur when y is equal to 0. In all my stubbornness, I'm still not going to use the quadratic formula. Let's see if we can get away with factorizing. I don't think we will, because they said something about leaving answers in third form. But anyway, so I'm timesing through by 24. So I've got 1 x squared minus a half times 24 is 12. And then 1 times 24 is 24. Any factors of 24 that add up to 12, well, negative 12? I don't think so. We've got 1 and 24, 2 and 12, 3 and 8, which is pretty close, but not good enough, and then 4 and 6, which is 10. So none of them work. So quadratic formula it is. For the first time in history. Let's solve. So x will be equal to minus b plus or minus b squared minus 4ac divided by 2 times 1. So I ain't gonna waste time, just gonna put this straight on the calculus. Right, so minus b, I'll start with the plus, and here we have negative 12 squared minus 4 times 1 times 24, and then down here we have 2 times 1. Give it to me in third form, hey boo. Okay, so the one solution is x is equal to 2 root 3 plus 6, or the second solution will be x is negative 2 root 3 plus 6. Yes, and it temp too nicely, because those decimals just phazamisad me. So let me just verify for myself. So this is minus 12, which is 12, plus or minus, and then minus 12 squared is 144. 4 times 24 is 96, and then down here we have 2. Then 12 plus or minus 144 minus 96 is 48. Okay, and then this guy, I just straight away with my intuition see that 48 is the same as 16 times 3. You could also put square root 48 into your calculator, and it should give you the simplified third form, right? Then if we divide 2 into each of these, we do indeed get 6 plus or minus 2 root 3. So calculator, you just, why didn't you give me the third form from the jump? Why? Anyway, so we now know that the x-intercepts, so let's just get this diagram. Okay. Past, man. Okay, thank you. Right, so we now know that our x-intercepts are given by 6 plus 2 root 3, 6 minus 2 root 3. So h is the first x-intercept, meaning that this will be, I need to put in my microscope now, so that I can write finely. finally, so this will be 6 minus 2 root 3. This one over here, this other x-intercept, just for fun, this one would be the one that is 6 plus 2 root 3 and 0. Right. Okay. Thank you, microscope, for your services. Right. So the question was, what is the horizontal distance between H and B? So we now know the x-coordinate of H is 6 minus 2 root 3. The x-coordinate of B is 6. The difference between them is therefore 2 root 3. Right? To go from here to here, from 6 minus 2 root 3 to just 6, means that I have traveled 2 root 3. So horizontal distance between H and B is 2 root 3 units, or you could say 6 minus 2 root 3. Remember to have your brackets. 6 minus 6 minus 6 minus 2 root 3, right? So then 6 minus 6 would cancel out, and then the minus would become a plus. So that's another way you could do it. Right. Okay, right. Wow. I'm so curious to see how the memo went about this, because I feel like my 5 million pages of workings are not make sure. Anyway, calculate the steepest gradient of the ramp. Very important thing here is also to note the domain of the ramp, right? So we're not just looking at the whole parabola in all of its existence. It's specifically, so if we bring our diagram, we're specifically looking at the domain from 0 to 12. Hey, where's my pointer? From 0, x is equal to 0 up until x is equal to 12. Right. So I want to bring this guy again, just because we worked so hard on it. So I'm going to delete you because you're boring. And then when I get, what is happening here now? Oh, guys, what is happening? Okay, so I think when I just move down, and then let's try to paste this thing again. Okay, that looks better. Right. Is this thing, okay, I don't know. Right, so we are trying to find the steepest gradient of the ramp. Okay, so did we find the first derivative? Sort of. Anyway, we'll just find it again. So we know that our function is that, the function of our curve, right. And so f prime will be given by 2 times 1 over 24, which is 2 over 24, or 1 over 12. And then here we're just left with minus a half. And then we want to see where, why is this still, hey, damn it. Sorry. So this changes from x squared to x. And we want to see where is this at its greatest. So let's have a look-see. So if we were to plot the graph of f prime, right, remembering that the domain, we're looking specifically at the domain where x is from 0 until 12. That is the beginning and the end of the ramp. So we're not even looking at, we're only looking from 0 until 12. So when x is equal to 0, the gradient of the what of the ramp is 1 over 12 times 0 minus a half. So that will be how? The y-intercept will occur at minus a half. Well, I mean, it's a straight line. Y is equal to mx plus c, y-intercept, so duh. And then let's see the end point. So when x is equal to 12, we have 1 over 12 times 12 minus a half. 1 over 12 times 12 is just 1 minus a half, which is not minus a half. I don't know if my voice just hypnotizes me sometimes. I just say things that I don't really recognize what I'm saying. Okay, I didn't want that to be right. So we have the gradient being a straight line like that, the gradient of this curve. So where is the graph, where is the curve at its steepest? This is the highest point, the highest gradient value in this domain from 0 to 12. This is as high as, yeah, the gradient is going to get. So steepest gradient is a half, and it occurs when x is equal to 12, or in other words, at the end of the ramp over here, which kind of makes sense. Right, yeah, I'd be surprised if there are any working out marks for that question. I think it was more like an intuition, what. Hey, let us see the fruit of our labors. We have, so they actually put the x-axis, or where we originally put it, so they put it down here, which, yeah, it makes sense. Honestly, if I had remembered that we have this value, I would also have just left the x-axis there. But okay, when you look at the memo and you look at these workings out, we're gonna have different functions, but our answers should still be the same. Right, so the nice thing actually about putting the x-axis here is that that would have given you your x-intercepts. So then you would be able to use the form of the equation y is equal to a, so it would have been this, and you would have known that it's a parabola that hasn't moved up or down, so then you don't have a plus anything element here, and then you would just need to figure out the a, which you could figure out using the coordinates of s. So actually it would have saved you a lot of work to put the x-axis there. Moral of the story is, hey guys, read, man, just read, take it easy and read. Right, so we have another option. So they also put the x-axis here as another option. The nice thing about doing that is then you have the turning point at 6 and negative 1.5. In fact, having this turning point, I could have used turning point form, man. I could have used y is equal to a times x minus 6 squared minus a half. And then all I would have needed to do is sub in 0, 1, 0, 1 to solve for A. So, yeah, the heartache of setting up simultaneous equations, guys, is just breaking my soul. But anyway, if there's anything that I am here to prove in life, it's that even if you take your 5-page solution, even if it takes that 5-page solution, you will arrive. You will arrive, my friend. Never give up, never give up, never give up, never give up, never give up. Right, anyway, moving along. Let's see what they had to say about the next question. So yes, this distance was indeed correct, 2 root 3. Just double check that. Yeah, 2 root 3. Then for this next one, hey, we arrived at m is equal to a half. As for how we arrived, I don't know. Okay, so let me try and understand what's going on here. So first up, we took the parabola's equation. We found the first derivative, which is 1 over 12x minus a half. Then we substituted 0 and we substituted 12. As for why, I don't know. I'm guessing it is for the same reasons. I don't know. Yeah. I don't know what to say to you. I hope that my explanation made sense. I can't really make sense of what the memo is doing, but okay. Thank you and bye-bye.